Hi, welcome back to class. All right, in our last video, we talked about key point modeling. All right, I want you to know that this video or this class is going to be a little much more interesting, right? This time around, we want to do what we call segmentation. All right, so in computer vision, there are different kind of objects that you want to detect, and there could be problems of occlusion, right? There could also be problem of trying to identify distinctly similar objects, but they are actually different. So how do you solve that particular problem? Aside from the fact that you can actually do object detection, track those things separately, you will still want to do something much more intuitive, which is called segmentation. So in this particular class, we're going to be diving into what we call segmentation in details. And we're going to be doing instance segmentation, semantic segmentation, panoptic segmentation, and we're going to be trying out some other segmentation tools that are open sourced, which is going to give you more practical understanding to how to actually segment any object. I look forward to seeing you in class. Stay tuned.
Welcome back to class. So in today's class, we're going to be looking at the topic segmentation. So, um, what are the different things we are going to be looking at when we are talking about segmentation? First, we are going to examine what exactly is segmentation. Then we are going to move on the different types. We are going to look at the different types of segmentation that we should be aware of as computer vision engineers or enthusiasts. So one of the types of segmentation we're going to be looking into is one, instance segmentation, and I will dive deep into what it means. Then we're also going to look at semantic segmentation, and finally we are going to look at panoptic segmentation. And those are the different types. Then we are going to look at what we call segment anything by meta. It's a segmentation algorithm and model that was developed by Meta, and I feel like it's something that you should be aware of and how to use them or how to build them. During our hands-on session, we're going to be looking into that particularly. All right, so what exactly is segmentation all about? So when we talk about segmentation, we're talking about in terms of images and videos. So when we say image or video segmentation, we are basically talking about it as a computer vision task that separates objects, boundaries, structures within an image or video for more meaningful analysis. So just take for instance, you have different objects, you've detected different objects, and then you really want to be able to distinctly separate them from an image for further analysis, or you are distinctly trying to crop them out or mask them out, and you want those boundaries clearly defined such that there's not another object interpolated or occluded with another object, right? You are literally looking at segmentation as the technique that can help you solve that particular problem. All right, so that's why we see it as a computer vision task that separates objects, boundaries, structures within an image or a video for more meaningful analysis. Now, image segmentation model assigns a label to each pixel, thereby indicating that it belongs to a specific segment or an object. So when we are looking at an image, for instance, a grayscale image, which is a two-dimensional array, so you are literally saying for a particular row and a particular column, given a particular row and a particular column, that's a pixel. So you are literally trying to say that you are trying to classify every pixel in an image to belong to a segmented object, or to belong to a specific segment or a specific object. So that is what segmentation model is all about. And segmentation model is so good to the extent that it is able to distinctly identify each pixels and separate them into the objects that they belong to. Okay, thereby indicating that this is this segmented object from this other segmented object, from this other segmented object, from this other segmented object. All right, the result of the segmented image often can be visualized as a mask or an overlay highlighting the different segments, or you can overlay just to literally identify the different segments. But most times people visualize it as a mask. You want to mask it out from the other object because it's the object of interest or it's the object of concern for further analysis. So what are the different types of segmentation that you should be pretty much aware of? So number one is instance segmentation. Now, what exactly is instance segmentation? This segmentation is based on differentiating between separate objects of the same class. Separate objects of the same class. For example, if there are many cats in an image, instance segmentation will identify and outline each specific cat. So what are we trying to say in this definition? We call something an instance segmentation procedure when you've been able to identify so many objects, right? But in this case, the objects belong to the same class. So when we say the same class, it basically means that those objects are the same, they are literally the same thing. It's just that they might be in different configuration. Maybe the cat is looking like this, the cat is looking here, but they are all cats. Okay, or maybe they are all dogs, or maybe they are all aeroplanes, they are all humans in the image. So you have like 5 humans that you've detected in the object. So we know that these people are all humans. So in a situation where you really want to identify Mr. A from Mr. B, from Mr. C, from Mr. D, and from Mr. E, instance segmentation is what enables you to uniquely identify Mr. A from Mr. B, and Mr. B from Mr. C, and Mr. C from Mr. D, and Mr. D from Mr. E. So that is exactly what we are trying to talk about when we talk about instance segmentation. So that type of segmentation is instance segmentation. Now, semantic segmentation is quite different. Now, according to the definition here, it says that this is to classify things and stuffs. So, things and stuffs. Things, in this case, refers to countable objects or distinct entities in an image with clear boundaries like people, flowers, cars, animals, etc. Stuff, in this case, refers to specific regions or areas in an image, different elements in an image like background or repeating patterns of similar materials which can be counted. All right, which can be counted. So that is what semantic segmentation is all about. So in this case, all we are concerned about with respect to semantic segmentation here is that, in instance segmentation, you have objects of the same class, but you are distinctly trying to identify object of the same class separately. But in semantic, you are literally classifying all cats to be cats. You are just trying to give them the same segment. They all belong to the same segment. So cats are different from cars, they are different from animals, they are different from flowers. So semantic segmentation literally means you are trying to classify things or stuffs or objects of the same category as the same category from objects from other categories. Okay, so semantic segmentation basically is classification based on the classes. Instance segmentation goes further by taking that class and you are trying to separate the objects that belong into those class into distinct objects. Okay, so instance segmentation is a little bit deeper in terms of segmentation than semantic segmentation. All right, let's keep going. So the last type of segmentation that we might want to observe in this lecture is panoptic segmentation. So what exactly is panoptic segmentation? Panoptic segmentation goes a step further in image segmentation of a computer vision task by combining the features and the processes of both semantic and instance segmentation technique. So for an image with multiple cars and pedestrian in a traffic signal, the panoptic segmentation will label all pedestrian and cars, that is semantic segmentation, and draw boundary box around them to identify and segment each individual person and cars. I hope that is clear. So literally what we are trying to say is that it draws a boundary box around them to identify and segment each individual persons and cars. So literally it's more or less like you are trying to talk about region of interest. So in this whole image we are concerned about the pedestrian, okay, everything on the pedestrian and the cars, okay. So that is panoptic segmentation, whereby you are trying to put together both instance and semantic segmentation in order to be able to take your region of interest for further analysis. That's panoptic segmentation. I hope that is making sense. Okay. Panoptic segmentation, it also detects and interprets everything within a given image. And panoptic segmentation leverages the strength of a fully convolutional network, that is FCN, for semantic context and mask RCNN for instance specific details, which gives a combined output for achieving a more holistic and nuanced understanding of visual data. Okay, nuanced understanding of a visual data. So I'll go again. Panoptic segmentation detects and interprets everything within a given image, and panoptic segmentation leverages the strength of a fully convolutional network, which we've observed in our previous class, FCN, for semantic context, and mask RCNN for instance specific detail. I hope that is clear, which gives a combined output for achieving a more holistic, announced understanding of visual data. So, last thing I would want to talk about before we go hands on is what we call the segment anything by Meta. Segment anything, like I always call it SAM, is a segmentation model developed by Meta that can actually cut any object in any image within a single click. Now, it's a powerful segmentation technique, which I would, do some demonstration with respect to how to use it. Okay, and literally what it does is that it's a model that has learned to uniquely identify or classify objects pixel wise. So it takes a particular region of interest. You just have to pick a region of interest or a point that you want to segment, and it takes that object, the object that is within that point, it segments it from every other object in that image. So it's a very, very powerful segmentation technique, and it works like magic. It's quite fast, quite reliable, and very, very effective. So it's a promptable segmentation system with zero shot generalization to unfamiliar objects and images without the need for additional training. When we say something is zero shot, what we mean is that you don't have to even train the model. You don't have it does it's so it has been so much pre-trained that it doesn't need to be trained in order for it to learn the features or segment the object you want to segment. So it is that vast, that powerful to be able to segment out whatever object or feature that you are so much interested in segmenting. All right, so that's the segment anything by Meta. All right, so we're going to go straight up into the hands-on implementation. But before I go into the hands-on implementation, I just want to give you a sneak peek into segment anything. So when you go online, and you can just basically type segmentanything.com. So if you go online, it's as you can see, that's literally look at this demonstration. You could basically see it demonstrates the demonstration in action, so it comes with a single click. You just have to pick the object within the image that you want to segment, and it does all the other magic. Okay, so segment anything model, the new AI model from Meta here that can cut out any object in any image with a single click. SAM is a promptable segmentation system with zero shot, blah blah blah, without the need for additional training. Used for a variety of input prompts. So you can see how it's able to segment the tortoise from the snail from the frog. And if you look at this, it's able to segment the tower from every other tower. Yeah? Generates multiple valid masks for ambitious prompting, so you can see how it's able to take out the jacket from the image. So that's what we're talking about here in action, and you can see it in action when it comes to AR VR, how it's able to how that is also integrated with respect to AR VR in segmenting things. So when you are looking at building technologies that involves you, they maybe you're trying to build an AR VR technology and you're trying to implement this integrate segmentation into it. So literally all you have to be worried about is the region of interest or the object you want to be able to segment. You can see that red stuff basically is an indication of the region of interest, and you see it basically keeps segmenting whatever the object is that has that red dot. So you can see the red dot, there's the red, and you can see that red stuff. So look at this cards, different. So you want to segment this cards from every other type of card you see. You just have to pick this, and then it does the segmentation. So it's a zero-shot generalization technique that has been trained so well to identify the different types of objects in consideration. So very, very effective. All right, so let's get hands-on. But before we go into talking about segment anything or blah blah blah, so going to go ahead into my downloads mouse. Okay, I want to just upload the image we're going to work with respect to segmentation. Okay, let's reconnect to Jupyter Lab since we're ready to work. Click on the upload. Downloads Timos. Okay, so that's the image we're going to work with. We're going to try and segment the person from the other persons. These are persons, okay, so we'll literally have to demonstrate some level of segmentation here. Okay, we have it uploaded. So let's get started. First and foremost, let's do some pip3 install ultralytics. Ultralytics. So that's very, very important with respect to whatever you're trying to do with respect to ultralytics. But first I want to just demonstrate segmentation, pre-trained models. So in this case, we are not trying to train. You can always follow the pattern with respect to how you can train your own segmentation model. Let's say you want to build your own segmentation model from scratch. So to train a segmentation model from scratch, or let's say to train your own custom segmentation model, let's not talk about from scratch. You can also check out the ultralytic documentation on how to train your own segmentation model from scratch. You just have to take the pre-trained model, follow through the things that we've done, the annotations and all of those things, and then export it into Google Colab and go ahead to train. So in this case, I'm just going to load segmentation pre-trained model, and to load it we are saying model is okay from ultralytic import YOLO, and then we say model is equals to YOLO, let's say YOLO 10, let's say YOLO 11n, so seg.yaml, or you can just put yo.pt. So it's either you pass in the YAML file for the YOLO, but it always loads the pre-trained segmentation model. Um, so that loads the pre-trained segmentation model, and then of course you can always generate, you can always train, you know, you've loaded the pre-trained model, then you can always do the model dot train. So don't forget you have to export, you have to do the annotation on on Ultralytic, on RoboFlow, export to Ultralytics, then it gives you that URL for you to now say model dot train. So but let's just go ahead and train the model on a Cocoa dataset. But in this case, I'm just going to use Cocoa YAML file to just demonstrate how you can train. So let's assume you have your own YAML file or custom YAML file. You just have to do it this way I'm going about, but it's still the same way we've been doing the model.train. Okay, so you can just copy that code from Ultralytics and paste it here after going through the annotation and the training and all. So in this case here, I want to just pass data is equals to cocoa8 seg.yaml, and then epochs, I want epochs to be, let's say, 100. Image size is, let's say, 640. So when you run this downloads the pre-trained model, does the importation of Ultralytics from YOLO, downloads the pre-trained model, so it's able to get the cocoa.seg.yaml images parts, but it's able to get that, then download the cocoa.seg.zip from Ultralytics. That's why I'm just trying to use that. Unzips the data set, does all those data, whatever. So this is the convolution model and the likes. Start the TensorFlow board for you to view, and view the TensorFlow board, see the processing and the likes. Downloads the pre-trained model into YOLO.pt, then scanning blah blah blah, because it has already downloaded the data set, 4 images, background, and then augmentation, blur, medium blur limit to gray, methods, then plots the label, then optimizer here is Adams, learning rate is 0.000119, momentum is 0.9, TensorFlow board, image size 640, train 640, validation using data loader, logging results to run/segment/train. So it's training the model already. I think we are currently at about it's almost done. That's quite fast. So now it's done training the model. So let's do some little evaluation. So it ran 100 epochs completely in roughly about 0.021 hours. That's minutes actually. Optimizer stripped, blah blah blah. Last of PT weight is 6.1 MB. Optimizer stripped. Best of PT 6.1 MB. So it always log the last model. That's if you want to continue if you want to resume training from the last model for another 100 epochs or for another 200 epochs. But let's go ahead and do some evaluation. So in this case, we are all classes. We have persons, dog, horse, elephant, umbrella, potted plant. So image size is, let's say, for instance, 17. So the bounding box precision for all is 77.7%, record is 91.5, mean average precision at 50 is 93.9, mean average precision between 50 and 95 is 68%, mask precision 70%, recall 84%, mean average precision of the mask 84.9, mean average precision between 50 and 95 is 56.8, and then it's went on and on like that for all the different classes. So this segmentation model should be able to segment persons, dog, horse, elephant, umbrella, but you can basically see for that of persons, precision is still quite fair. 74%, 58, 66. Well, we can still manage it that, but of course we can definitely increase the number of training. So there are some recalls here. I'm seeing 100% here. That's for dog, horse, umbrella, potted plant. So it's really going to be very good at that. Okay, so let's do some let's run some. That's how to do the training. So let's go ahead and do some results. Let's run inference. So we already have model here, so let's pick up this URL and then run some inference, and let's see what we come up with. So we have model results is equals to model, and then you pass in the path. So, and that runs it. So it's we're going to go ahead to display speed 4.1 milliseconds, inference is 56.7 milliseconds, image shape, that's one of the, so channel 3448 by 640. So let's display. So for let's do results 0.show. So let's display the result, and let's see if we're able to get some segmented results. I hope this is making sense. Alright, so while we are trying to wait for that, so we're going to go ahead to do some, to demonstrate or to try out segment anything by meta. Segment anything by meta. But I want to wait for this result. So while I'm waiting for the result, let me just go ahead to segment anything by meta, text. Segment anything by meta. Alright, so let's observe. Okay, see, this seems cool. So you can see it's able to segment persons. So what kind of segmentation is this? You basically see it categorize all of them together as persons. So that is semantic segmentation at work here. Alright, so semantic segmentation. Alright, so let's try out some instance segmentation using segment anything by meta, because this time we have to specify the object we want to segment here. So first and foremost, if you go into segment anything by meta, you can access their GitHub instructions here. Facebook research / segment anything 5.8 Fox, 5.8K Fox stars for now. That's quite a number of people using it. So time, image encoder, memory. So these are some things that we might actually need to learn. Memory attention, mask decoder, prompt encoder, that's the mask, the points in the box. Very pretty technology right here. Welcome back to, okay, so let's take a look at we've been able to take a look at segment anything. So let's go ahead to download and install segment anything. Okay, so what I'm gonna do here is to create a new text and then say segment anything. Okay, so next is I'm gonna do the pip install. So just gonna pip3 install. Okay, so this is how to run the pip install, and once you are done with respect to installation, that gets you the model from Facebook completely installed. Next is we're going to have to download the model weights. Alright, so the model weights for we're going to download one of the segments, the open source model. You should be able to find that on GitHub. you can download model checkpoint from here. So click on this link, copy link address or something. Okay, so GitHub Facebook research slash segment anything. So the model checkpoints we're going to use is this slash sum vits h4b 8939.pth. Okay, so let's just see if that has been downloaded. Let's reload this. So QMe is quiet. GitHub, Facebook. Okay, so instead of doing that, let's do dir.com. So let's say dir.fb ai pub leak files.com slash segment underscore anything. So you have to get this URL right. Segment underscore anything slash so you run this, and this downloads this file quietly. Okay, so we have the model downloaded from source code. All right, so next is let's try out this segment anything model and run it on some of our images. So first we have to import touch, then from segment anything import some model registry. So in this case we want device to be touch.device. I'm sure we are familiar with this. So we want CUDA 0 if touch.CUDA is available, which we have to check if we actually enabled that. So from what we have here, if we look at our runtime, change runtime type. Okay, so we are GPU enabled. All right, so which means device here would definitely be CUDA. Then we need to also specify that model type is VIT. So there are different types of models with respect to segment anything, but we choose to go with the VIT H SAM model. So checkpoint point path is literally the path to those models, so you can just copy paths and paste, and then SAM, then we can now initialize the SAM model registry, model type, and specify the checkpoints. Checkpoint is equals to check point path. Okay, then we can now move SAM to device, because we want this to run on SAM.to device is equals to device. Okay, so if we run this successfully, that loads the model, sets so that's literally import SAM registry, initialize device. All we are just trying to do here is to load model to device, load model to GPU, or let's say device. In this case, device here is GPU. Okay, all right, so next is to run some inference on the image that we have. So we're going to be saying import cv2, and then of course from segment, so we need to also import um, SAM auto, is what we call the SAM automatic mask generator. Yeah, then of course from google.colab.patches import cv2 imshow, because we want to be able to display our results. So mask in this case is imports. Okay, mask generator is equals to SAM, of course we need to initialize that, SAM auto mask generator. Then you pass in our SAM into that, and then of course the image part. So the image part in this case is the stimulus. So that's the image path, and next is to convert the image to BGR. Read as a BGR, imread image path BGR. That's going to read it as a BGR, and of course to RGB. So cv2 cvt color is equals to image BGR into cv2 color BGR to RGB. Okay, that converted to, so now we can now run inference. So mask generator dot generates, so we want to generate mask for our RGB image, and then when we run this we have the result, and then we can basically take a look at what result looks like. Oh, our coder is out of memory. Try to allocate 38.6, total process 89 points. Okay, so generates, so mask RGB image BGR. What I'm thinking, okay, let's see, what's the model weight? That's another thing. So this model weight is roughly about 4 gigabytes. Okay, that's interesting. So how many GPU? So we recently just ran out of GPU. So there's an overload here. Okay. So let's another thing that we can do is to properly resize the image. So image BGR, then we can basically say image BGR is equals to cv2.resize image BGR. So let's just say we want to resize it to, let's say 600 by, let's say 400, and then we convert it to RGB, and let's see if that's going to keep the data not too much for processing. Of course that worked, so we just resized the image, because definitely the BGR image was larger. So in this case we have the results area. So let's take a look at what the result looks like, because I want us to learn. So it returns a bunch of arrays. So it returns the segmentation mask, false, true, then area, then the bounding box of the persons that was detected, the predicted IOU, point coordinates, stability score, crop box, segmentation. That's this segmentation 2. The same thing, area prediction, then segmentation 3, segmentation 4, segmentation 5, segmentation 6, segmentation 7. Wow, this seems like there's a lot of segmentation. All right, so different level of segmentation here. So if you look at learn of results here, it's about 40 different segmented images. All right, so but in this case I want us to, so now let's do some level of visualization, but I want to try to introduce you to a new library, supervision by RoboFlow. So I'm just going to because I want you to be very familiar with some of this. So let's do some pip install. So you can actually do visualization with your matplotlib or OpenCV, but of course let's try out some new libraries and then get familiar with them. Supervision. All right, so let's run this. So we have that installed, so I just want to just leverage on using supervision, introducing into supervision as SV, and see how we can actually work with that package or that library to do some visualization of our results. So mask annotator, like mask annotator has to be initialized because we want to visualize a mask from our segmented results. Mask annotator. All right, so color lookup. You might want to look at some of their segmentation, some of their documentation with respect to supervision. Is a very, very interesting library for computer vision. Index. So it's a very interesting library for computer vision, and then you might want to learn how to use some of those libraries for your computer vision projects from SAM results. Then we can say, okay, we've got the detection, which is from SAM results. So annotated image is equals to mask annotator dot annotate, which is image BGR or RGB. Should we do BGR or RGB? Then detections. Because we ran result on BGR or RGB, we ran it on RGB, right? So let's image RGB. So we have annotated image. So let's run this. And next is, let's do a CV2 imshow of annotated image. So let's see what comes up with. So you can basically see it is able to segment the background, give it a color, segment the hair, give it a color. See, this is another segment, also segmented this top from a skin, or segmented this face from, so you can basically see it's all unique. The air, the glass, the hand, all unique. So that's what we call, you are literally trying to like give everything a unique instance level of segmentation. All right, so definitely you can always visualize mask, and I just had to introduce you to um, this level of segmentation with respect to um, the usage of segment anything. And I want to believe you've learned one or two things. So one of the things I want you to actually try out is to take some random sample images from take some other images, play around with it, take a look at take some random images and play around with this segment, um you know segment mask generator. So initially it will always, you have to first of all initialize the mask generator like this, and then of course you pass in the mask generator right to the image. Okay, so you might also want to take a look at some of the, so they also did some guide with respect to so the model can then be used in few lines to get the mask from a given prompt. So there's a way you can also prompt the image to actually focus on where you want to segment. So you can see some model registry, some then procedure to set passing your image, and then you can also put in the inputs, like you can prompt it, oh, where is the hair or something, and then it gives you the mask of where the hair is. Or you can generate mask for an entire image, which is what we actually did, and it gave us about 49 um 49 different masks in the image. So you might want to also study the export web, and some other thing, model checkpoints. So defaults, so VITH SAM model. So you can always copy the model from here. That's the link. Copy link address. That's the link. So if you paste it, you see which is the one we worked with just now, and it's about 4 GB. So we have H, we have the L, and we have the B. Alright, so default is the H. Then of course there are different types of data sets of the data set. The data set can be downloaded here, so these are things that you can actually get yourself familiar with. You can always try to learn about these technologies, how you could use them, and how they could be of great value to you or to whatever you're trying to build or implement. All right, so I want you to also take note of this documentations and references.
Welcome back. And I want to say great. You've done really, really well. Thank you for listening, and thank you for paying attention to every detail shared within this particular class. And I want to say that I'm so excited and proud of how you are growing with respect to your learning and with respect to your career. Yes, you are becoming a computer vision engineer, but of course, definitely you've got to finish this course. All right, so there's going to be a little assessment for you with respect to this particular class. Don't forget, you've learned how to segment objects, which is you've learned to do instance segmentation, semantic segmentation, panoptic segmentation. So why don't you just try it out on something very much more intuitive? So that's what the assignment is all about. So follow through the guide as described in the notebook, step by step. Definitely that is what we've been doing all this while. You know that this is quite very intuitive. So follow through the document, follow through the instruction step by step, and I look forward to seeing your answers. I look forward to seeing your response, and definitely we'll be seeing you in the next class.